Good day, everyone. Today we'll be looking at numerical processes which have to do with indices and logarithm. And before I start, I want to give the laws relating to what indices. So let's start. If, for instance, I have a square multiplied by a cube, this simply gives me a raised to power 2 plus what 3, giving me what a raised to power 5. This is simply the multiplication law, which states that if I have a raised to power b multiplied by a raised to power, let me say c, since the two bases are the same, I simply add the power, giving me a raised to power b plus c. This becomes our first law. Our second law has to do with the division of indices. If I have a raised to power b, I have divided by a raised to power c. This simply gives me a raised to power b minus c. That's to say, when two indices of the same base are to be divided, you take one of the two bases, you subtract the second expression, the second power from the first power, whereby the a are the base and bc are the powers. So our third law, let's talk about the zero power law. If I have a raised to power 0, any term or expression raised to power 0 is simply 1, provided that base, a in this case, is not equal to 0. Because if it equals 0, then we have a term or an expression that cannot be determined. Our fourth law of indices is the reciprocal law. Let's say I have a raised to power minus 1 or a raised to power minus b. This is equals to 1 all over a raised to power b. That's to say, when an expression is raised to a negative power, I can simply say the reciprocal of that expression, removing the negative power. Our fifth law is simply the product law. Let me say I have a raised to power b, close bracket, c. This will give me a raised to power b times c. That's to say, when a base have a power enclosed in a bracket raised to another power, you simply take the base and multiply the two powers. So these are the first 5 laws. Let's move on to another one. Let's say 6. If we have a raised to power b over c, this is same as saying a is equal to the root of c raised to power b. This same as saying the power a raised to power b first before the root of c. This can be written in any form. Both are same. So these are the laws of indices. And remember, if I have something like a, let me say this 7th, a raised to power minus b over c, this is simply 1 all over a raised to power b all over c, which goes further to give me 1 all over the root c root b, c root a rather raised to power 2. So That's it. But if this was A, let me say A over B raised to power, let me say minus C over D. To remove the negative sign, I can simply say the reciprocal of this. Reciprocal of A over B will give you what? B over A. Then you have it in brackets, you have your C all over what? D. And you can go further to have this, which affects the top and the bottom, to give me D, B all over A, all raised to power what? C. So this, with these 8 laws I've written here, we can go on with solving. The solving will give us a better insight about the laws of indices. So let's start with our examples. So we have 3 examples on the blackboard, and please get me. My plight here is to make sure you understand the reasons for each answers. If we have 10 raised to power 5 times 10 raised to power 4, remember our addition law says when indices are being multiplied, we simply take the base and we what? Add up the power. Why? Because of the multiplication sign here. So this simply gives us 10. This is 10, this is 10. So I take one of the base and I'll add up the power because of the multiplication sign. So I have 5 plus 4, giving me what? 10 raised to power what? 9. And remember, 10 raised to power 9 means 10 times 10 times 10 into 9 times. So this is 5y times 4y raised to power 4. First, we focus on the numbers. This becomes what? 5 times what? 4. We put a multiplication sign and focus on our y. This 5y have an invisible positive 1 as power. So I have my 1. Multiplication is what? Or let me say y times y raised to power what? 4. This becomes what? 5 times 4, which is 20. And y, this is an invisible 1. So I have 1 plus 4, giving me what? 20y raised to power what? 5. And for this, I have 9 times 10 raised to power 9 divided by 3 times 10 raised to power 3. I can simply use this to divide this, and I'll use this to divide this. But an easier way is to say 9. 9 is same as what? 3 raised to power what? 2 times 10 raised to power 9 all over 3 times 10 raised to power what? 3. So I simply pick 1, 3 relating to this and this. Or I have 3 raised to power 2 all over 3 times 10 raised to power what? 9 all over 10 raised to power what? 3. Now this is division sign. So I have 3 raised to power 2. There's an invisible 1 here. Because of this division, I'll have minus. I'll put my 1 times. I'll write my 10. I'll write my 9 at the top. And division sign is what? Minus. I'll put my word 3. This becomes 3 raised to power 1 times 10 raised to power what? 7. 9 minus 3. 6 rather. So this will simply give me 3 raised to power 1 is 3 times 10 raised to power what? 6. 10 raised to power 6 is simply what? 1 million. So if you choose to write like that, you can say 3 times 1 million to give you what? 3 million. But this is good enough. So we have other examples here. We have x raised to power 3 divided by x raised to power minus 5. How do we resolve that? Remember, we have xx as the what? Basis. Now, the power is 3 and what? Minus 5. We have a division what? Signed. The rule says for division that if I have x raised to power a divided by x raised to power b, this will simply give me x raised to power a minus what? B. So I'll do that here. We simply we'll pick one of the base, which is what? X. And we'll pick our first number, which is what? 3 as power. Division is what? Subtraction. and I have negative 5, I'll have my negative what? 5. This will simply give me x raised to power 3. Minus minus is what? Plus 5. Giving me x raised to power what? 8. Our second example here on the board is 3x close bracket raised to power what? Minus 3. Solving this, the first thing I will do is to remove my negative sign. And remember, we have when a is equals to minus b, this is same as saying 1 all over a raised to power what? B. So you take the reciprocal of the entire expression, then you remove the what? Negative what? Sign. So this becomes 1 all over 3x close bracket raised to power what? 3. And we can have this as 1 all over this 3 affects this 3 and this x. So you can write it as 3 raised to power 3, x raised to power 3. And 3 raised to power 3 is not 3 times 3, which is 9 please. 3 raised to power 3 is 3 into 3 places, which is 3 times 3 times 3. 3 times 3, 9. 3 times 9, 27. So we simply have 27x raised to power what? 3 as our what? Answer. Our next example here, we have a. We have a raised to power minus 9 divided by b raised to power 0. Now we have this simply a raised to power minus 9. Remember, the two bases are different, so we cannot combine them. But b raised to power 0 is 1, because we said any value raised to the power of 0 give us what? 1, provided the base is not equal to 0. So b is not equal to 0, therefore b raised to power 0 is what? 1. So we have a raised to power minus 9 divided by what? 1, which gives me a raised to power what? Minus what? 9. And to remove the negative sign, I can have 1 all over what? A raised to power what? 9 as my what? Answer. Our last example on the whiteboard is 24x raised to power 6 all over 8x raised to power what? 4. Now 24 cannot be expressed in the power of 2. 8 can be expressed in the power of 2. So what I simply do, or cancel out, 24 divided by 8 is what? 3. So I have 3x, this x raised to power 6, and I'm left with what? X raised to power what? 4. Now focus on the x. I have 3x raised to power 6. I'll use one s to replace these 2x, and this 6 is already here. Division is what? Minus. So I have minus what? 4. Giving my final answer as 3x raised to power 2. We have 5s squared times 4s raised to power 0 times 2s raised to power minus 6. So we simply use the law of indices to resolve this. This will simply give me 5s squared times x raised to power 0 is what? 1. 4 times 1 will give me what? 4. I'll have times, this can be written as 2 all over x raised to power what? 6. Which gives me a positive value of these 2s raised to power minus 4, minus 6. So therefore, I simply have 5 times 4 times 2 times, I'll bring my s to this side, x raised to power 2 all over x raised to power what? 6. This becomes 5 times 4, 20 times 2, 40. So I have 40 x raised to power 2. Division is what? Minus 6, which will give me 40x raised to power minus 4. This is same as saying 40 all over x raised to power what? 4. So we have this 15 times 10 raised to power 4 divided by open bracket, 3 times 10 raised to the power minus 2, close bracket. How do we resolve this? Remember, this is same as saying 15 times 10 raised to the power 4. This division is same as this, 3 times 10 raised to the power minus 2. Doing this now gives us a better insight on how the question ought to be solved. Now, 15 divided by 3 is what? 5. I'll have times 10 raised to the power 4. I can say all over 10 raised to the power minus 2. And this will be written as 5 times 10 raised to the power 4. Subtraction is what? Minus. So I have minus 2. So I have 5 times 10 raised to the power 4. Minus minus is plus what? 2. Giving me 5 times 10 raised to the power what? 6. 10 raised to the power 6 is a million. So 5 times a million will give you what? 5 million if you choose to. We have 3m raised to the power 4, or close bracket, square. But I have to simplify. How do we simplify this? Remember, this 3 affects this square affects this 3, and it also affects what? M. This can be solved as 3 raised to the power 2, m raised to the power 4 times 2, giving me 3 raised to the power 2, which is 9. 3 times 3, 9. Or let me write it out. 3 times 3, I'll have my m raised to 4 times 2, which is what? 8. Giving me 9m raised to the power what? 8. Somebody else can still decide to say 3m raised to the power 4 in bracket square will give me 3m raised to the power 4 times 3m raised to the power what? 4. And I'll have 3 times 3 times m raised to the power 4 times m raised to the power 4. 3 times 3 is what? 9. I have 9m raised to the power 4. Multiplication is addition, which is 4. Giving me 9m raised to the power what? 8. So, in either way, you still end up at the same what? Answers. We have minus a square m, all in bracket, raised to the power 2. How do we resolve this? This can be resolved as negative a square m times negative a square m, which gives you negative is what? Positive. So we have a square m times a square m. If I pick one of my, this can be written as a square times a square times m times m. Pick one of the a. Multiplication is what? Addition. So I have 2 plus 2 times m, invisible 1 plus invisible what? 1, giving me a raised to the power 4, m raised to the power what? 2. If you decide to work further, this is same as saying a2, a square in brackets square and m what? Square, which can be written as a square m, all brackets square. Because this times this will still give you a raised to the power 4, and this times this will still give you m square. So you can end it up this way, and you can end it upwards this way. We have a raised to the power 6 all over minus a, close bracket, raised to the power 4. How do we resolve this? We see that a and minus a are not of the same base, because this is positive a, this is negative a. So let's try to resolve the denominator first, giving us a raised to the power 6 all over minus a raised to the power a times minus a times minus a times minus a. But another thing you need to know, I can also decide to change this negative a as minus 1a raised to the power 4, which now gives me minus 1 in bracket raised to the power 4 and a raised to the power 4. And when you have a negative value raised to an even number, it gives us what? A positive value. So minus 1 raised to the power 4 will give me positive 1, and a raised to the power 4 remain a raised to the power 4. In the same way, if I multiply this, minus minus is plus, plus minus is minus, and minus minus is what? Plus, and I'll still have my a raised to the power what? 4. So take note. So this gives me a raised to power 6 all over a raised to power 4, which therefore gives me a raised to power 6. Take one of the base, division sign minus what? 4, giving me a raised to power what? 2. We have minus c in bracket raised to power 2 times c raised to power 4 divided by minus c in bracket raised to power 5. How do we solve this? You can see that while this is negative c, this is negative c, so they can be collected or work together alike. This simply gives me what? Minus c in bracket raised to power 2. Division is minus, so I can pick my what? 5 times c raised to power 4. This will give me negative c raised to power what? Minus what? 3 times c raised to power 4. This and this cannot be combined. So this will give me what? 1 all over. This become negative c raised to power what? 3. Positive, because I use the reciprocal what? Law to remove my negative sign. And I have times c raised to power what? 4. This therefore can be written as 1 all over. If I say minus 1 raised to power 3, it will still give me minus what? 1, because it's what? A power of an odd number. So I have minus, and c raised to power 3 will give me c raised to power what? 3. I'll have my times what? C raised to power 4. And I'll have minus c. Pick one now. I can pick one. C raised to power 4 and what? Negative what? 3. Negative 3 because of what? The division sign. Or let me write it out so you can understand. This will give me negative. This will give me negative c raised to power 4 all over c raised to power 3. And this will become negative c raised to power 4. Division sign is minus 3, giving me minus what? C as my final what? Answer. We have minus open bracket d square close bracket raised to power 3 divided by d raised to power 4 times minus d. How do we simplify this? First, you must take note that our raised to power 3 is not affected by the negative sign. So the negative sign remained the way it was given. And 3 can be used to multiply these 2 using our what? Power what? Rule. Because if I have a raised to power 2, a raised to power, let me say b all over c will give me a raised to power bc, and bc is multiplication. So this becomes d raised to power 3 times 2 will give me what? 6 all over d raised to power 4 times minus d. And this can be used to cancel this. So I have d raised to power 4 all over d raised to power 6 rather over d raised to power 4 times d. And this will give me we have d, d, and d. I can pick one of the base. I'll write my 6. I have my minus in brackets 4 plus this invisible power 1. So I have 4 plus what? 1. Because the multiplication they are to be added. Remember. So this will give me d raised to power 5. 4 plus 1 will give me what? 5. So I have 6 rather minus what? 5. Which gives me what? D raised to power 1. And anything raised to power 1 is that same what? Expression, which is what? D as our final what? Answer. We have 25a squared or close bracket raised to power half. How are we to solve this? Remember that this power half here is affecting the 25 and is also affecting the a square. So we use it to multiply the what? Powers. The power of 25 here is 1. So I have 25 raised to power half, a raised to power 2 times what? Half. This can be taken as square roots. So we have square root of what? 25. A raised to power 2, 2 cancel to have root a, root 25a. Our square root of 25, remember, should be plus minus of what? 5. Or I can go further to say this will give me 5 raised to power 2 square root plus minus a. and square will cancel square root, and I have plus minus what? 5a as my what? Answer. We have 2 raised to power half times 2 raised to power 3 over 2. First, you can see that the bases are same. So I'll pick one of the base and I'll add the powers because of my multiplication what? Sign. So I simply have 2 and 2 as x here, which is what? 2. 2 into 2, 1. 1 times 1, 1. And 2 into 2, 1. 1 times 3, 3. Giving me 2 raised to power 4 over 2. Giving me 2 raised to power 2, which is equals to what? 4 as my final what? Answer. We have 2a in bracket raised to power minus 1 times 3a squared. How are we to do this? The first is to remove our negative sign. So we have 1 all over 2a raised to power what? 1. But anything raised to power 1 is 1. Is that same what? Expression. So I can remove my 1. I'll have times what? 3a what? Square. So this can be written as 3a times a if I choose to, which is 3 times a all over 2a. And this a can cancel this 2a, and my final answer will be what? 3a all over 2. We have 8 all over 27 raised to power negative 2 over 3. How do we simplify this? First, remember if we have 1 over a, or let me say b over a, raised to power minus c over d. So remove my negative sign, I'll tell you the reciprocal of b over a. And the reciprocal of b over a is what? A over b. So I'll now remove my negative sign to become c over what? D. That's the same we do here. So 8 over 27 raised to power negative 2 over 3. To remove my negative sign, I'll have what? 27 over 8 raised to power what? 2 over 3. Now, for this, my 3 as a power have to do with roots, and my 2 have to do with what? Power. Now I'll have the third root of what? 27 over what? 8. Close bracket raised to power 2. I will advise you take the third root first, so that there won't be an increase when you take the power first. So 27 can be written as what? 3 raised to power what? 3. And 8 can be written as what? 2 raised to power what? 3. Third root square. Now this can be written as 3 and 2, which is what? 3 over 2. Close brackets raised to power what? 3. Third root in brackets square. So cube root can cancel what? Cube. Cube root can cancel cube. So we therefore have 3 all over 2 in brackets square. This becomes 3 square over what? 2 square. 3 square is what? 9, which is 3 times 3, and 2 square is 4, which is 2 times 2. So these are final answer, which can be written as 2 number 1 over 4. We have another question on the board, which is the third root of 4 raised to power 1.5. Now, the first thing we should do here is to convert our 1.5 to what? Fraction. So I'll have the fourth root of what? The third root rather of 4. 1.5 is same as what? 15 over 10. Now I'll break it. I'll have the third root of my 4 remains. 5 here is what? 3. 5 here is what? 2. So I therefore have this. So these roots, this power, they can cancel out. So if they cancelling out, it's like I have the third root here. I have 4 raised to power 1 over 2 in bracket, and I have 3. So you see the roots can, the cube root can cancel the what? Cube. So I therefore have 4 raised to power what? Half, which will give me the square root of what? 4. since anything raised to power 1 will give me that same value. And square root of 4 will give me plus minus what? 2. We have 16 over 9 in bracket raised to power minus 3 over 2. How do we simplify this? The first thing I do is to interchange this so as to remove this negative sign. So I have 9 over 16 in bracket 3 over what? 2. Now after this, my bottom is root, my top is what? Power. So I have the square root of 9 over what? 16, all raised to power what? 3. Now, square root of 9 is what? 3. Square root of 16 is what? 4. Remember to put your plus minus, because whenever you take square root, it should be positive and at the same time negative, except things relating to time, ages. That's when you neglect your negative what? Sign. So we have raised to power 3. So we have plus minus 3 raised to power 3 means 3 times 3 times 4, 3. And 4 raised to power 3 is 4 times 4 times 4. 3 times 3 is 9. 3 times 9 is 27. So I have plus minus 27 all over 4 times 4, 16. 16 times 4, 64. So we have plus minus 27 over 64 as our what? Answer. We have 3 raised to power n minus 1 times 3 raised to power 1 minus n on the whiteboard. How do we resolve this? These two bases are same, so I simply pick 3. And I have my n minus 1 as my first power. Multiplication is what? Addition. I can put brackets 1 minus what? N, which is the second what? Power. So I have 3 raised to power n minus 1, but 1 multiplying the bracket gives the same signs, which is plus 1 and minus what? N. Now, we try to arrange the what? Powers. So I have 3 raised to power n minus 1 plus 1. So we have 3 raised to power n minus n will give you what? 0. 1 minus 1 will also give you what? 0. So we have 3 raised to power 0. And anything raised to power 0 is 1. So my final answer for this expression is what? 1. We have the third root of 8a raised to power minus 6. We have to simplify. How do we do this? But first, we remember that our minus 6 affects only the a, it does not affect the 8. While our third root affects 8a raised to power minus 6. Now, this is my third root. I want to remove my negative sign for a first. So I'll simply have 8 all over a raised to power what? 6. Now, this can be written as the same third root of what? 8 all over a raised to power 6 can be written as a raised to power 2 close bracket raised to power what? 3. And I can decide to split this to give me the third root of what? 8 all over the third root of a square raised to power what? 3. So the third root of 8 here is what? 2. Because it can be written as 2 raised to power what? 3 all over this already on its simplified what? Form, which is 3 here. So this we cancel this and I'll have what? 2 all over cube, we cancel cube root, or have my what? A square. So this can be 2 all over a raised to power 2 or 2a raised to power minus 2. When it comes to the top, it carries a negative what? Value. So these are my what? This is my what? Answer. We have 0.125 raised to power minus 1 over 3. We have to simplify this. How do we do this? The first thing is to convert our decimal number to what? Fraction. 0.125 is same as what? 125 all over what? We have 4 digits, so we have what? 1000. Because I need 3 zeros to multiply this to give me what? To remove my decimal what point. So I have 3 zeros attached to what? 1. So this remains minus 1 over 3. Now the next thing I have to do is to remove this my what? Negative sign. Removing it, since it's a fraction, I interchange a what? Fraction. So become 1000 all over 1 to what? 5. This can be written as 1 all over 3. Now the negative sign has been what? Removed. Now I don't need to break down, because I can see that I can express 10 to power 3 and I can express 1000 rather to power as 10 raised to power 3, and I can express 125 as 5 raised to power what? 3. So I simply have 10 raised to power 3, which equals 1000, and 5 raised to power 3, which equals to what? 125. All raised to power 1 over what? 3. I can therefore take one of these. I have 10 over 5 raised to power 3 in brackets 1 over what? 3. So this can cancel this, or have 10 over 5, which is equals to what? 2 as my final what? Answer. We have 4a raised to power 3b times 3ab raised to power minus 2. How do we resolve this? We'll focus on the two numbers, which is 4 and 3. So we have 4 times 3 times, we'll focus on our a's, which is a raised to power 3 times what? A. We'll focus, excuse me, we'll focus on our b, which is b times b raised to power what? Minus 2. 4 times 3 is what? 12. Times, we have our a. This is a raised to power 3. Times is plus, so this invisible 1 plus 1 times b raised to power invisible 1 times is what? Plus minus what? 2. Now we have 12a raised to power what? 4. 3 plus 1, 4. And b raised to power 1 plus minus is what? 1 minus what? 2. So we have 12a raised to power 4, b raised to power minus 1. 1 minus 2 is minus 1. This can be written as 12a raised to power 4 all over b raised to power 1, which is equals to what? B. So this is our what? Answer. We have 4a raised to power 3b times 3ab in bracket raised to power minus 2. How are we to resolve this? This is not like the previous example, because if you observe this, the bracket here, the negative 2 here is affecting 3ab, but the previous one is only affecting the what? B. How do we do this? So we simply have 4a raised to power 3b times 1 all over, to remove my negative sign, 3ab in bracket raised to power what? 2. 1 all over, I've removed the negative sign here. So we can resolve this and resolve this separately. This will give me 4a raised to power 3b all over. The square affects everything inside. So this becomes 3 square, a square, and b what? Square. This will give me 4a raised to power 3b all over. 3 square is 9. A square, b square. This become, if you want to save yourself the stress, you can simply have 4, or let's follow the normal method, 4 over 9. We'll have our a raised to power 3 minus the value of a here, which is 2, and b raised to power invisible 1 minus, which because of the division sign, 2, giving me 4 over 9 a raised to power 1, which is a, and b raised to power minus 1. This can be written as 4a all over 9. We bring b to the other side, to downward, the negative sign will be removed. So we have 4a all over 9b as our what? Answer. We have 75a raised to power 2, b raised to power minus 2, all over 5a raised to power 3, and b raised to power minus 3. First, we can cancel out 75 divided by 5. 7 divided by 5 is what? 1, remainder 2, into 25, 5. So 75 divided by 5 is 15. I'll pick 1a, which is, I'll have my 2 here. Division is minus, so I have minus what? 3. And I'll have b raised to power minus 2, division minus, and the value of b as power here, which is minus what? 3. This will give me 15. A, 2 minus 3 is minus 1, and b minus 2 minus minus is what? Plus 3. This will give me 15. A raised to power minus 1, b minus 3 plus minus 2 plus 3 will give me positive 1, which might be neglected if you choose to, because b raised, ordinary b is still b raised to power 1. So we have 15b. If this goes down, to remove the negative sign, we have all over what? A raised to power 1, which is what? A. And this is my what? Answer. We have 2x in bracket raised to power half multiplied by 2x raised to power 3 in bracket raised to power 3 over 2. How are we to resolve this? Remember, this raised to power half affects the 2 and the x. So we can have 2 raised to power half times x raised to power what? Half times 2 raised to power 3 over 2 times x raised to power 3 times what? 3 over what? 2. This remains 2 raised to power half times x raised to power half times 2 raised to power 3 over 2 times s raised to power 3 times 3, 9 all over what? 2. Now focus, I'll combine the terms that are alike in terms of base. So I'll have 2 raised to power half here times 2 raised to power 3 over 2 times x raised to power half times x raised to power 9 over what? 2. Now I'll pick one of the base, which is 2. I'll have my half, because of my multiplication I have plus what? 3 over 2 times x. I'll have my half, because of my multiplication I'll have plus what? 9 over what? 2. This therefore will give me 2. XM of the powers 2 and the XM or denominator of the powers is what? 2. So I'll simply have 1 plus 3, which is 4 over 2 times xn of denominator is what? 2 all over addition of the two top. 1 plus 9 is what? 10. So I'll have 2, and I'll have 4 divided by 2 is what? 2 times x raised to power 5. 2 raised to power 2 is what? 4. So I have 4x raised to power 5 as my final what? Answer. So we have 18 over 32 in bracket raised to power minus 3 over 2. First, let's remove our negative sign. So we simply have 32 over what? 18 raised to power 3 over what? 2. So the reciprocal of this, I've removed this negative what? Value. And 2 here will give me what? 16. 2 here will give me what? 9 in bracket 3 over 2. Remember our 2 is roots. So we have the square root of what? 16 all over what? 9. All close bracket raised to power what? 3. Now, square root of 16 is what? 4. Square root of 9 is what? 3. Remember to add your plus minus all over raised to power 3, which gives me what? 4 times 4 times 4 raised to plus minus all over what? 3 times 3 times what? 3. So I have plus minus 4 times 4 16. 16 times 4 is what? 64. And 3 times 3 is 9. 9 times 3 is what? 27. So we have plus minus 64 over 27 as our what? Answer. So we have this. We should write the expressions using positive indices only. Positive indices simply means that we should all the negative signs should be removed from these words, values or what? Expressions. Now to remove my negative value here, I'll simply have 1 all over a raised to power 2 as my answer. This I'll have 1 all over b raised to power 1, but b raised to power 1 is what? Same as b. So I have 1 over b as my answer. This I'll simply have 1 all over c raised to power 2 over 3 to remove my negative sign, which is same as 1 all over the third root of c raised to power what? 2. The fourth is this negative 1 is affecting only the y, so I'll simply have x over y raised to power 1, which is same thing as x over y as my answer. The fifth is affecting both the x and y. The negative sign is affecting the x and y, so I'll simply have 1 all over what? Xy raised to power 1, which is same thing as 1 over what? Xy. And this is affecting, this negative sign is affecting only the 2, only the a, so I'll have b raised to power 3 all over what? A square as my what? Answer. So again we have this ab raised to power minus 3 will give me what? A all over b raised to power 3, because the negative 3 is affecting only the b. So if I bring b to the bottom, I will have the negative sign removed. This is affecting the a and b, so I have 1 all over ab raised to power positive 3. This can be written as 1 all over a raised to power 3, b raised to power 3. And this, the negative half affects only the x, so I have 2 all over x raised to power what? Positive half. And half is same thing as square root of a value, so we have 2 all over the square root of what? S. If you say raised to power 1, it will still give you what? With what? X. We have 3y raised to power minus 2 over 3. The negative 2 over 3 is affecting only the y. So we have 3 all over y raised to power what? 2 over 3. This can be written as 3 all over the third root of y all raised to power 2. And this, we have a all over 3b affected by 1 over what? 2. The 1 over 2 here is affecting both expressions. So I can interchange the words inside values to give me what? 3b over a raised to power what? Positive half, which can give me the square root of what? 3b all over a. If you say raised to power 1, it will still give you the square root of 3b all over what? A. And lastly, I have 1 over n raised to power negative 1 over 3. If I interchange 1 over n, the negative sign will be removed. So I have n over 1 to give me positive 1 over what? 3, which will give me n raised to power 1 over 3, which will give me the what? Third root of what? N raised to power 1, which will give me third root of what? N as my final what? Answer.